This is a video to help you learn how to write reactions in which a solid forms a type of double replacement reactions. Sometimes we'll call them the precipitation type. It's a good idea to get out note sheet H1 so that you can follow along and use H1 as a reference. Notice that we're reacting two compounds with each other, and there is a switch in the compound. So now A is bonding with Y and B is now bonding with X. So there's quite a few steps that one would follow in order to be successful writing and balancing double replacement reactions that form a precipitate. These steps might look a little bit intimidating, but we'll do one example, and then you may use this note sheet to go on and practice 6 samples. So step 1 that you want to check is to look up to see if these two compounds that you start with are soluble in water. And of course, if we had the chemicals in front of us, you could test it. But otherwise, you need to use the back of your periodic table and use the solubility rules. So lead nitrate, a salt, remember, is any ionic compound. Any compound that contains nitrate, including lead 2 nitrate, will be soluble. So yes, we know that this compound is soluble, meaning it will dissolve in water. Next, we need to look up the potassium iodide, and potassium is an alkali metal, and all alkali salts, alkali anybody, so potassium iodide will be soluble. So yes, we know that this compound is soluble. That allows us to move on to step 2, which means let's use these words and make a switcheroo. Let's switch lead and potassium's places and write the substance as lead 2 iodide and potassium nitrate. And now step 3, we need to look up the solubility of these two chemicals. Well, lead 2 iodide. Iodides are generally soluble except with lead. So that means that this compound, this lead iodide, is going to be not soluble. That means we're going to call it the precipitate, which we symbolize with PPT. The second compound, potassium nitrate, is an alkali nitrate, and that certainly will be soluble. And so this substance will be broken apart. Remember, when ionic compounds are soluble, they break apart into separate ions. So now we're ready to write the skeleton equation, which is step 4. So we would write Pb with its 2+ charge, and nitrate, NO3, 2 of them, because nitrate carries a 1- charge, and that reacts with potassium iodide, each carrying a +1 and a -1, forming lead 2 iodide, lead with a 2+ charge, iodide with a 1-, and potassium nitrate, each of those carrying a +1, -1 charge. We can once again remember that these substances are soluble. That means they will be broken apart into ions. Lead iodide is not soluble. We would identify it as the precipitate, and potassium nitrate is soluble. Now we do need to balance this equation. That will be step 5. So I'll come in with the blue pen, and we see 2 iodides and only 1 on this side, so we'll need to put a 2 in front. And then that, of course, means we'll need 2 potassiums, which also gives us 2 nitrates, and that's good because we've got 2 nitrates on the reactants side. Lastly, we'll need to turn this into a net ionic equation. And remember, what that means is we're going to eliminate the spectator ions, the ions that don't change. Because nitrate is originally dissolved and separated as nitrates, and it is at the end, we can drop the nitrates out. And because the potassium is separated, meaning we see this squiggly line in both places, on the reactant side and the product side, we can eliminate the potassiums. And so that all that's left remaining will be lead 2+ ions, 2 iodide ions, so we'll write 2I- turns into the insoluble precipitate lead 2 iodide, ending with our net ionic equation. Whatever ions are in that precipitate, we need those to form that product.